Hi everyone. Today's lesson is all about the distributive property and using rules. We talked about finding common factors and factor pairs of larger numbers between 1 and 100. So today we're talking about the distributive property. You've already learned a little bit about distributive property in Miss Sloan's class. In this class, I'm kind of taking you backwards. In her class, she probably showed you how to multiply the number on the outside by the numbers on the inside. Today, I'm kind of going to show you the reverse side of that, but one thing at a time. Okay, the first slide is a video lesson. That's what you're watching right now. The next slide is giving you real world examples and why we use common factors, why it's important to use, and just how to connect it to the real world. So using this knowledge that you've learned the past couple of days, we're going to solve this problem. The problem is if there are 40 girls and 32 boys who want to participate in sixth grade intramurals. This is like sports teams. If each team must have the same number of girls and the same number of boys, question one, what is the greatest number of teams that can participate in intramurals if each team has to have the same number of girls and the same number of boys? How many teams can that be? The second question is how many girls and boys will be on each team? So we're going to do one question at a time, and you've actually already done this in yesterday's lesson. What you have to do to find the greatest number of teams is you have to find your factor pairs and then identify the common factors of 40 and 32. So on this next slide, we're finding common factor pairs for 40 girls and 32 boys. So thinking back to your divisibility rules, you want to ask yourself, can I divide 40 by 1? Yes, I can. 1 times 40 is 40. So 1 and 40 are factor pairs. Can I divide 40 by 2? Yes, 40 is even. I know that 2 times 20 would be 40. Can I divide 40 by 3? No. Can I divide 40 by 4? Yes, I know that I can do 4 times 10 to get 40. Can I divide 40 by 5? Yes, I know that you can do 5 times 8 to get 40. Can't divide it by 6. We can't divide it by 7. We already have 8 down, so these are all the factor pairs of 40. I also have to do the same thing for 32. Okay, I can divide 32 by 1 because 1 times 32 is 32. I can divide 32 by 2. You may not be sure about how many times 2 can go into 32. So if you want to, you can scroll down to the bottom, all the way down, and I have some division places set up. We can do 32 divided by 2. 32 divided by 2. 2 goes into 3 one time. 1 times 2 is 2. We subtract and get 1. Bring down the 2. We have 12. 2 goes into 12 6 times. 6 times 2 is 12. We subtract and we get 0. So 2 goes into 32 16 times. That means 2 times 16 is 32. So we'll go back up here and I'll do 2 times 16 as a factor pair. And then go to the next number. Can I divide it by 3? No. Can I divide it by 4? Yes. I know that 4 times 8 equals 32. Can I divide it by 5? No. Can I divide it by 6? No. Can I divide it by 7? No. And then I come to 8. I've already put the 8 there. That means that it's not going to go into anything higher than that. So These are all of our factor pairs, all of the factors of 40 and 32. So I want to know how many teams of equal boys and equal girls we can get. So I can make teams of 1 because we have a common factor of 1. We can make teams of 2. We have a common factor of 2. We can have 2 teams. We can make 4 teams. We have a common factor of 4. We cannot do 5 teams. We could do 8 teams. We have a common factor of 8. We cannot do 10. We don't have a common factor. No common factor of 20. No common factor of 40. No common factor of 32 or 16. So 1, 2, 4, and 8, these are all common factors. We can divide 40 and 32 by these numbers. Okay, the question is, what is the greatest number of teams that can participate in intramurals? We don't just want one team. If we had one team, that wouldn't really be fun. 2 teams wouldn't really be that fun. You'd play one game, you'd be done. 8 teams is the largest amount of teams that you can have participate, so we're going to put 8. 8 is the greatest number of teams that we can have. Okay, the second question that covers this slide is how many girls and boys will be on each team. So we're going to use that greatest common factor to solve these problems. Okay, we're going to also use the distributive property, which you learned in Miss Sloan's class. I'm going to be reviewing it a little bit with you today. So the number that's on the outside of the parentheses is going to be that greatest common factor, that 8. And then we have to figure out what the number on the inside of the parentheses would be. So in this slide, if we only have 8 teams, I want to know how many girls would be on each team and how many boys would be on each team. Okay, so if I originally have 40 girls and I split 40 girls up into 8 teams, I'm really dividing 40 by 8 to get the number of girls per team. 40 divided by 8 is 5, so I would have 5 girls on each team. 8 times 5 is 40, so the distributive property would work. For the number of boys, if there are 32 boys split into 8 teams, 32 divided by 8 would be 4. So on each team, we're going to have 5 girls and 4 boys with 8 teams. Okay, you're going to practice filling out that distributive property for 3 questions. Okay, question 1, it gives you the question, and then you have to fill in the teal squares on these 2 slides for question 1. Question 2 gives you the information. Answer the questions in these slides. Question 3, information, 2 slides. All the other slides are just there if you need to use your work for anything. Again, if you have any questions about any of this, let me know, and I'll help you out the best that I can. Good luck.